Right, so we're learning about Samuel now, and Samuel invests exactly 14,500 at 8.5% per annum compounded monthly for 3 years. Calculate the effective interest rate, correct two decimal places. So we're looking at the effective interest rate. How do we calculate the effective interest rate? How do you calculate the effective interest rate? Right, so the effective interest rate focuses on a couple of things. Right, you need to remember that to calculate the effective interest rate corrected two decimal places, we have the formula for the effective interest rate. Right, so how do we calculate that one? You need to remember that in 8.3.1, we have the formula that says 1 plus I effective is equal to 1 plus I nominal over m raised to the power m. And this is the formula we use. Right, so we take this formula and we use exactly this formula here. Right, so if we then say, if we want to calculate the effective interest rate, correct to two decimal places, right, so we want to find R effective. Right, so R effective is 1 plus the nominal interest rate. Right, we have the nominal interest rate. The nominal interest rate is exactly 8.5% there, okay? Right, Eunice, I was looking for you. So you have 8.5%, right? So if you have 8.5%, yeah, I can even call you after my class, Eunice. Um, yes, I'm just having an online class now, but I was looking for you today, but now you're not there. I was calling you on the phone. You're not picking up. Yeah, yeah, but yeah, I'm gonna reach you after my class. Okay. At about 10:30. Okay. All right. Okay. Thanks, Ines. All right. Great. Thanks. Goodbye. Okay. Now, if you look at the 8.5%, now you divide by 100, right? So you need to divide this by 100. And if you do, what do you get if you divide 8.5 divided by 100? So to look at it, you can just say take the 8.5, you divide it by 100, but also it's 12, compounded monthly, it's 12. So you can just say 12 times 100, okay? So it's actually the same as just dividing the 8.5 by 100. Then you raise it to the power. What is the power? Right, so the power is actually exactly 12, then you minus 1, okay? So this is it. So now if you use your calculator to find the effective rate, so what you do, you note the formula. What is the formula for the effective versus nominal rate? It is 1 plus R effective equals that, okay? So as you continue right now, what does this become, right? So it becomes exactly the following, right? So it becomes precisely this. 1 plus, right? 8.5 out of 12 by 100. You raise it to the power 12 and then you minus 1. Right, so you get exactly this one here. Okay, if you use your calculator, you get exactly 0, 0, 0.8839. Okay, now obviously you can multiply this by 100. You multiply it by 100, this decimal comma is going to move two places. 1, 2, 1, 2. Making it 8.8, right? 8.839%. So that is what we get. So we get exactly that one. So we get 8.8 39%. So that will be the effective rate. Okay. So now in 8.3.2, if he withdraws 5,000 after 3 years, and the interest rate drops to 7.8% per annum compounded quarterly, calculate the total amount of the investment after 2 more years. Okay, so let's look at this one and look at it very carefully. Right, so we're going to be looking at 8.3.2 up here. Right, we're going to realize that Samuel is actually doing an investment and he invests 14,500 at 8.5% per annum compounded monthly, but this investment is for 3 years. I said yesterday, and I'm going to say again, if they give you a question like this, where they give you like 3 years, and then they mention 2 more years, and then they mention 5,000 after 3 years. So you need a timeline for this just to avoid confusion. So you say time 0, time 1, time 2, time 3. And then you analyze the question as follows and say, what do you do in a situation like this one? Right. So what you do is you then say, someone invests 14,000. So if Samuel actually invests 14,000, you need to realize, therefore, that the 14,500 is actually an amount of money that's invested right now. If you invest money that's available. So it's present, it's a present value, right, of 14,500. But he invests it at 8.5% per annum. 8.5% per annum compounded monthly for 3 years. Right. If he withdraws, okay, look at this. He invests this one at 8.5 compounded monthly for 3 years. So if it's compounded monthly for 3 years, now you say 3 times 12. So which is 36. So it's going to go on up to T36, okay? Going to go on up to T36. Why T36? Because it's monthly for 3 years. So if it's 3 years, then you multiply by monthly because there are 12 months in a year, so you get 36. So now it means that this is going to be the investment for the 3 years. So if you withdraws 5,000 after 3 years, there is 5,000 that is being withdrawn. So in other words, the understanding is therefore that 5,000 there is actually removed after the 3 years. And the interest rate drops to 7.8%. It drops to 7.8% per annum. Right, compounded quarterly. So you need to calculate the total amount of the investment after 2 more years. Right. So in other words, the interest rate drops to 7.8% per annum, compounded quarterly. So now here you are dealing with monthly rate. And here is quarterly. From T36 is quarterly. Okay. Now, it drops to 7.8% compounded quarterly. Calculate the total amount of the investment after 2 more years. Okay. Right. So there are a couple of things we need to obviously look at that. So I want us to look at the question very carefully and understand the question, because they're saying here if he withdraws 5,000 after 3 years. So after 3 years, he withdraws 5,000. And the interest rate drops to that component quarterly. Right, calculate total amount of the investment after 2 more years. So after 2 more years, you need to add 2 more years. So 2 more years times 4. Because a year has 4 quarters. Right, so you have 8. Yeah, right. So that's going to give you 8 quarters in the 2 years. Right. So obviously now, if we're dealing with the quarters here, we have 8 of them. So if you add 36, T36 to, you add 8, what do you get? You get 44. So T44. Okay, this timeline sort of helps you to get the things right and to avoid confusion. Okay. So we want to calculate the total amount of the investment after 2 years. So we want to sort of know an amount A there. Okay, that's sort of going to be available. So how do we actually calculate these here? So we do it as follows. We take the 14,000. We take the 14,500. Right? 14,500 that's being invested. Yeah. And if it is invested, it's actually invested for 3 years. And we're interested in knowing how much it's going to be. So in other words, this 14,500 is subjected to a rate of 8.5%. Right. And if it is for 3 years, what is this going to be? So there are a couple of ways over to do this question. One way is to use the nominal rate. Another way is to use the effective rate. So the easiest way is to say to the students, always use the formula. If it's monthly, etc., use the formula 1 plus I over m to the power n m, because it's monthly, quarterly, etc. So this obviously becomes the nominal rate formula. So it meaning that you just gonna take the 8.5%. So you can use the nominal or the effective rate, which you got before. So now you take it's monthly, so it's 12 months by 100. You raise it to the power there. How many years are there? There are 3 years by 12. So that is what the 4,000 is going to be in the 3 years. Uh-huh. So it's going to become exactly 18,000. 694,83. Right, so it's going to become 18,694,83. And then next, what do we say next? Next we say 5,000 is withdrawn. So in other words, you're going to take the amount of money you, because now these 5,000 is withdrawn, so you minus it, you subtract it. So you have 18,694,83. You minus the 5,000, right? You minus the 5,000. Then you're gonna look at the rate. What is the rate now? It's 7.8% compounded quarterly. Right. So you're gonna have the 7.8%. You divide it, so you can just take 7.8. Okay, normally you can just write 7.8. Then you say, if they say quarterly, there are 4 quarters in a year. If they say monthly, there are 12 months in a year. So quarterly is 4 quarters in a year times 100. Right, so you raise it to, because it's just 2 more years. Okay, we said it's 2 more years. So it's 2 more years times 4 quarters. So it's, you can say it's 2/4. You subtracted 5,000 that was withdrawn, and then now the amount continues. And therefore, this is exactly 15,000. 982.87. Like this. So this becomes the amount of money that is, so calculate the total amount of money or total amount of the investment after 2 more years. So the investment is going to be just 15,982 Rand and 87 cents. Okay, thanks so much for trying that other question. Okay, so there are a lot of finance questions we shall be playing with. So stay tuned. Right, let's look at more finance. Right, so then there are more finance questions because now we are working from the end. Chem 4 to other worksheets that focus on finance as well. Right, because I want us to finish the finance. Right, we did SIPO, we did Zakele, and we converted the rates. We did the two, we did Center, we did William. Okay, I'm looking for just other questions on finance that we can most certainly study and make sure we understand. Right. So we have that. I'm looking for more finance, more finance. Right, more finance that is new and done finance. And then we're gonna spend time on some trig as well, but I want us to first exhaust finance because that is what is important for us. But that is what is likely to obviously gonna dominate, I believe. Gonna be more dominant. So I need to make sure that we understand that very well. Okay, those are the exemplar assessments, but the other assessments that we need to master, like this one's here, like these ones here, okay. Lots of these, lots of these, lots of that. So you have that. You have that, you have that, you have that. Let's see what you have. Okay. Asanda, Mrs. Pillay. Okay, we're gonna do this one. Right, Kai, assuming inflation, amount of that. Cabo, Asanda inherited Mrs. Pillay. We spent some time on this already. Right, Jonathan, a car, value of that 10 years ago to the nearest rand. We spent some time on this. 3 and 4. Right, I think that's okay. Let me see how much of it is there in the beginning. See how much finance is there. Then I can focus on the finance that is there. Right, so yeah. So we're keeping on the finance. That's good. Targeted worksheet 1. Right, so let's recap on the finance. So we're going to be crushing finance today. So yeah, stay put because I want to make sure we exhaust all finance in this workbook. Okay. So yeah, all finance. And then the next thing we're going to crush is probability and the other sections as well, the Venn diagrams. But yeah, let's look at a lot of the finance part. Okay, so a lot of the finance part. Okay, so we're gonna just be cruising through together. Let's look at this one. So I'm gonna give you a chance like to do the questions alongside with me. So yeah, for example, now question 1, determining the investment value, accumulated amount. Jonathan deposits 3,000 into a bank account. The bank offers an interest rate of 15% per annum compounded monthly. Calculate the amount that Jonathan will withdraw after 6 years. Let's do this question. All right, so obviously note that this one here is the topic on finance is targeted worksheet 3. Right, so if I give you this one for a minute, what would you think the answer is? Okay, what do you think the answer is?
I'm doing it now, sir.
You're doing it, eh?
Yes, sir.
Okay, thank you. Thank you. Because we're just practicing. Okay, we're just practicing. You let me know when you're done. Right. You have your calculator with you, right? Okay. Um, just confirming that you have the tools you need to tackle the question. But because it is an investment, okay, let me check quickly. Right, you got 773. That's fine. No offense. No offense. So what we do, we're gonna do it together. Okay, let me just put this one down here. Right, determining the investment value, which is the accumulated amount. So the investment value, which is the accumulated amount, what is it? It is actually A. We're looking for the investment value, the accumulated amount. That's what we're looking for. So Jonathan deposits 3,000 into a bank account. The bank offers an interest rate of 15% per annum compounded monthly. Calculate the amount that Jonathan will withdraw after 6 years. Jonathan can only withdraw money that is available. So because it is an investment, we use the formula with a plus. Right, because it's compounded monthly, we use the nominal interest rate. So we divide by M, but we also raise to the power N, then we multiply by M. He deposits 3,000 into 1 plus 15%. So if it's 15%, here, what do we do? So you take the 15%, you divide by, because it's compounded monthly, you divide by 12. You put also 100 here, you can do this. Okay, monthly, then you always divide by 100, the percentage. Right? And then you look at the fact that it's how many years this? After 6 years. Calculate the amount that Jonathan will withdraw after 6 years. So it's 6 years times 12. What is the answer? Right, you might be right. So I need to check because I did not do this myself before. So right, let's just check quickly. So it's exactly 3,000 into 1 plus 15 out of 12 by 100. Right, you close and it is to the power 6 by 12. Right, 6 by 12. So the answer you're getting is yes, well done. 7337,76. Okay, so that is exactly what you're getting. So that's the amount there. So it's 7337,76. Yeah, excellent, excellent stuff. Next question. Determining the principal amount. So we're looking for the principal, right? The principal is P. And so the car has a current value of this much, right? There's a current value of 250,000. If the value depreciated at 13% per annum compounded quarterly, calculate the initial value of the car, right? Initial value of the car 10 years ago, based on a reducing balance method. Round off the answer to the nearest rand. Okay, how do we do this one? Because we're speaking about a car that's depreciating, we use the formula with the minus, you agree? So we're going to use the one, but it's compounded quarterly. We use the formula with the minus, but we use this one over M raised to the power n M. So, all right, so we substitute everything. Can you do this? And tell me what the principal is going to be. I'm waiting. And then we're going to do corrections. Okay, let me know when you're done, please. Right. Let me know when you're done. Okay, please let me know when you're done. All right. Okay, please let me know when you're done. All right, let me see what you got. Right, you got 9 to that. So let's just check what that is together. You must have got that pretty much right, I believe, that we are checking together. So, right. So the couple of things that obviously we need to actually do here. So we're gonna do this and say, want to get the principal value. So the principal means you divide by this guy here. So if you divide by this, you therefore have P equals A divided by 1 minus I over M to the power NM. What is this? Um, so right, a car has a current value of this one. If the value depreciated at this one compounded quarterly, calculate the initial value of the car 10 years ago based on the reducing balance method. Right. So obviously at this point, what you need to do is to calculate the value of P. Yes. So what is the value of P? Because the car is the current value of these. If the car depreciated at 13% per annum compounded code to calculate the initial value of the car 10 years ago. So we're interested in actually calculating the value of the car 10 years ago. So obviously we agree, therefore, that the actual value is 250,000. right, into 1 minus the 13%. Divide by, okay, it's compounded quarterly, so it's 4 quarters in a year times 100. Raised to the power, how many years are these? 10 years, but by 4 quarters. 10 years by 4, and then you get the result. So if you do this, you'd get actually the result. Okay, this is an interesting question, but you need to obviously make sure you understand it. Right. And then I want to check your answer. You might be right. Right, but I need to calculate it because I did not do it before. Right, so you have 250,000 and you have 1 minus 13 into 4 times 100. Mm, okay, you close here and raise to the power 40. So it's 937 348,44. Why is that? Why is it different from yours? Then check that again. All right. Because now we're saying the car is a current value of these. If the car depreciated at these, compounded quarterly, calculate the initial value of the car. So in other words, it is the current value of these, but it had a value before that depreciated. So the value was present that depreciated to this. How much was it? So we are obviously calculating the initial value of the car 10 years ago. Right, and it's actually this. Okay, so that is what I'm certainly getting. Um, that's what I'm certainly getting. Okay, so yeah, we continue. We continue. Right. Let's look at this one. Determining the nominal interest rate. Okay, let me see. What you thinking? Okay, use the same method, but the answer is different. Why? Why is the answer different? What makes you think? Um, if you put this on your calculator, does it give you 937? Can you do it again? The Google. Can you put this on your calculator and see what answer it's giving? Okay, please just try to do this on a calculator and see if it's not giving you this. Because I can see it's giving you 9.2. Okay, I got 9.3 when I put this on my calculator. Can always be a small discrepancy. Yeah, but it's worth checking. It's worth checking. It's worth checking. All right. I know, I'm sure you're still checking that. I'm sure you're still checking that part. Maybe it's a small discrepancy, you round it off somewhere, that kind of thing. All right. Right. Determining the nominal interest rate R. Sipo invested 15,000 in a banking account, right? After 5 years, he withdraws 28,000. Calculate the interest rate rounded to two decimal places per annum if it was compounded half yearly. What do you think is the answer to this one? Let me give you like another 2 minutes for you to try. This question about SIPO. Please let me know when you're done. Please let me know when you're done. Determining the nominal interest rate R. People invested 15,000 in a banking account. After 5 years, they withdraws 28,000. Calculate the interest rate rounded to two decimal places per annum if it was compounded half yearly. All right. Please let me know when you're done. Because I'm trying to make sure that we skim through, we go through the finance questions. But I want to give I want to give you a chance to practice along. Okay. Right. Continue. So let me know when you're done, please. Okay. Please let me know when you're done because I'm interested in us solving these questions. Right, you have sent the image. Right, so you got 0, that for 7. Let's see if that is the correct answer. Let's see if that is the correct answer. Okay, we are practicing. Right, so let's do it together. I'm just going to put this one on the side because we need to check. Need to check the answer. Right. So let's do this. Right. So obviously we're looking at Sipo invested 15,000 in the banking account. After 5 years, he withdraws 28,000. Calculate the interest rate rounded 2 decimal places per annum if it was compounded half yearly. So because now this is nothing other than an investment, we're going to use the formula that says A equals T into 1 plus I over M to the power NM. Yeah. So look, calculate. Yeah. Sipo invested 15,000. After 5 years, he withdraws 28,000. He withdraws 28,000, but he invested 15,000. So the present value, whatever you invested right now. So it's the present is the principal. He withdraws that one in a certain number of years, right? 5 years. 1 plus the interest rate, that's what they want. Calculate the interest rate because if they say it's compounded half yearly, I just prefer use this formula because it's half yearly, so it's quarterly, etc. It works well. Right. So now you then say, okay, this is what they want. Okay, they just called it R there. You can use R, but I feel right. It's compounded half yearly, so it's twice a year times 100. Okay, you always divide the percent by 100. Then obviously it's 5 years times what? Times 2 because it's compounded half yearly, 2 half years every year. We divide 28,000 by 15,000. 1 plus I divided by 200 to the power 10. So which means that we have, what if we divide the board here? So would have, yes, my dear. All right, fine, thanks. So yeah, okay. So let's just finish that up. Okay, so we continue right now. Right, so we're gonna take the 10th root. Right, so if you take the 10th root, right, so you have the 10th root of 28,000 divided by 15,000, which is the 10th root of 1 plus I over 200 to the power 10, which is the 10th root, 28,000. One plus I over 200. Okay, you subtract 1, you multiply by 200. So the 1, you bring it across. So it's going to become the 10th root of 28,000. You divide by 15,000. You minus 1, which has been transposed. So you transpose the 1 and you multiply by 200 in the denominator. This is going to give us I. Okay, let's check what this one is going to actually give. Okay, because this is the answer. So let's just do it. I'm just doing it here now. Right, so it's going to become exactly the 10th root of 28,000, 15,000 minus 1 times 200. So I becomes 12,88. Oh, okay. Okay, you're saying it did not multiply by 200. Okay, I get your point. Right. So right, because the answer is exactly that one, which is 12,88 um percent. Right. So yeah, so I prefer that because the formulas themselves can potentially be confusing. Right. So because the formulas can potentially be confusing, you can just use the nominal rate. Yes, Kakul. Yes, all is well, Kakul. Yeah, yeah. Okay, that's fine. What time is it? Okay, in the morning. Okay, that's fine. We keep in touch then. Okay. All right. That's okay. Yeah, that's fine. We'll discuss the details because I'm having an online lesson now. Okay. I'm having an online lesson now. Okay, thanks, Kakul. All the best. Okay, thanks. Goodbye. Mhm. Yeah. Okay, so that's the answer. But I'm sure you understand what's happening. Is that correct? Okay. Next one. Because you see, by saying you try, I'm trying to see the kinds of mistakes that you are likely to make so that you correct those mistakes and you can do better. Because I believe that mathematics is a doing subject. So if you do it, then you're going to learn. Let's look at targeted worksheet 3. Right, there are a lot of finance questions here. But first, we're going to look at 3.1. I'm going to give you this one to try. The 2,650 was invested in a fund paying 5% per annum, compounded monthly. After 18 months, the fund had grown to a value of this. Calculate the interest rate. Right. Please just do this one in the least amount of time. I'm trying to see the mistakes so that you can correct them, you know, and just make sure that you like become perfect. Because if I do this myself, you'll be like, okay, I've seen, all right, then the problem with seeing only, you can just believe you have seen and you understand. But yeah, mathematics, you need to do it. It's like a sport. In soccer, you don't watch and believe that you can go and play in the field, on the pitch. In soccer, you need to watch, but also you need to go into the pitch and play, into the field and play. Because if you don't get on the pitch to play, and then now you just watch, after watching, they say play. You see, the fans, some fans would, they watch a lot of soccer, but if you put them there to play, the fans cannot even do anything. So please try 3.1. Okay, please let me know when you're done. I'm trying to see the mistakes. I'm not fault hunting. I'm not trying to cause you pain or stress, anxiety. No. That is not the aim. Okay, you're done, right? Okay, thank you. Oh, all right. Let me give you a little bit more time. I'm trying to see mistakes so that I can be like sure of what needs to happen. Right. Okay. Right. Let me see what you got. Right. You got exactly that one there in 3.1. Right. Remember, we are looking at this one. So, yeah, we're going to check this one here. But obviously, we are really saying this amount of money, 26,000, rather 2,650, was invested in a fund paying 8%. It's an investment, so but it's compounded monthly, etc. So this investment that are compounded monthly, I prefer that you use the nominal rate formula. So you already divide by M and you have M and M like this. And then now, if it's compounded monthly, but this is the amount of money that was invested. After 18 months, the fund had grown to the value of these. So in other words, this is what was invested, the principal. So, but it grew to a value of 3,004.53. It is 2,650 into 1 plus. Then you have 5% per annum compounded monthly, right? And then now it's 12 months in a year, right? After 18 months, so you put 18 months there. So you just put the months because there are no years. Just put the months. All right. So we want to get the I. So you divide this, which is 3,004.53. You divide by 2,650, and this is actually 1 plus I over 12 raised to the power 18. Right? You take the 18th root of both sides, which means you're going to have the 18th root of 3,004.53 divided by 2,650. Okay, you have taken the nth root and then you subtract 1. After subtracted 1, you also multiply by this denominator. You multiply by 12. Right, so if you multiply then by 12, it is actually equal to I. This must be the I. Okay, because they're saying calculate the interest rate. So we're looking for the I. Right, so in 3.1, let's just do it. So now this is going to be exactly 18 into 3004.53 2650 minus 1 times 12. Zero, eight,
I'm
four,
sorry, sir.
0. Right, so you get this one?
Sir.
Yes, please. Okay,
Hello, sir.
yes, please. Okay, the comment, eh? You are referring to the
Hello.
comment, right?
Yes, sir. I multiplied the 12 by 100, but I remember now that we only do that when we have the value of I.
Okay. All right, I get your point. I get your point. I get your point there. I actually get your point. It's a very interesting point you actually bringing. Right, to say, when do we multiply by the 100 and when don't we multiply by 100? Okay, you can multiply by 100 as well.
Sir?
You can multiply by 100. You can choose to multiply by 100 always.
Oh, okay.
Okay, so I know I did not multiply by 100 here, but I feel that it's the same thing, but you need to, okay, the best is just to multiply by 100 always. So I can just multiply by 100 always. We can agree that we multiply by 100 always. So that there's no confusion. Okay, because it will always be correct either way. Okay, the answer will just differ by a factor of 100. Okay, so I feel that let's just have that agreement because we can do it both ways, and the books use both methods. But now I feel that we can just always multiply by 100 here. Always. Then you have 18. Because always you will divide the I by 100 anyway. Because the I is a percentage. So you'll always divide it by what? By 100. Right? So you come here. So here you have this one, 12 times 100. So it's like 1200. It's equal to I. So it's going to be the same. The answer is just going to be, it's going to be a full percentage now. Okay. So if you divide by 100, the answer you're going to get is going to be a percentage. So, for instance, if you use a calculator, because I'm just doing it, let's just, just to avoid confusion, because one can be like, when do we multiply by 100 and when do we not? Okay. So you can multiply, just always multiply by 100, but always do that. So the answer will just, so here, if I multiply by 100, it's very nice. If multiply by 100 because what do we get? If multiply by 100. So if multiply by 100, it becomes exactly a percentage. So we get 8.4% already. So we don't, but you see, before we got 0.0 something, then we'd have to know that we need to multiply by 100. But this one automatically multiplies by the 100. So everything is ready, and we obtain a percentage straight away. Okay, but just note that. Okay, so I'm trying to make sure by allowing you to try these questions with me. But now I'm then saying, if they speak of an investment, if they mention an investment, use the formula with a plus. But the minute they say monthly, quarterly, like here they say monthly, you divide by M. But you need to know that this M must have 100. It must have what? 100. Because that 100 is always part of this.
So I used the exact same method as yours, but I got a different answer.
Yeah, that is what is surprising to me. Can you put this actually on your calculator? All these, punch these,
Maybe it's my
calculate.
calculation or something, but I'll try again.
Yes. Okay, because I want us to get like the same answers, so that our answers like both agree. Okay, so that our answers actually always agree with each other. Always agree with each other. Okay, next question. The next one is Kai. Kai is a long story. But let me give you like 2 minutes because it's like 2 marks. Okay, let's read the question to make sure it makes sense to both of us. Kai bought a new car 4 years ago. Okay, they mentioned 4 years ago, so it's like N. He now wants to upgrade to the latest model. 4 years ago, he invested 60,000 for 4 years at an interest rate of 9.6% per annum, compounded monthly. He will use the investment to pay cash for the new car and use the old car as trade-in. Calculate the value of his current car if he paid. Now, this is what you need. It's not just the whole story, but it's what we want. So it's not, you should not be confused by too many things. Calculate the value of his current car. If he paid 160,000 for it and it depreciated at 12% on a reducing balance, round off to the answer to the nearest rand. What are we supposed to do? To find the value of the current car if it depreciated, he paid 160,000 for it. So if he paid 160,000 for it, we're asking the question, it then depreciated. What is the 160 that he paid for it? Because he paid 160, but it depreciated. So in other words, we want to calculate the value of his current car. Right. So want to find the value of his current car. Okay. If you pay 160 and then it depreciates, how much is it going to be? So yeah, try the 3.2. Try 3.2. It's a long story, but yeah, you don't need to look at the many figures that are there. You need to look at what actually needs to be done. Please let me know when you're done. Like I said, you always use, let's just always use 100 in the denominator, because in the end, we're just going to use the 100. Because even if we decide not to use the 100, but yeah, it's going to come up somehow. So we just need it. Okay, we just need it. All right, so please let me know when you are done, because I'm trying to see what mistakes you can make so that you can like correct them. But as I said, in this long story, you don't need to be confused by everything. What you're supposed to do, calculate the value of his current car if he paid this. Okay, if you pay these here, it means that you pay this now, and this is the principal. We want to find the value of his current car. So if you pay this, so you want to find the value is I, all right? If you depreciate it, it's I, which is this one, on a reducing balance. So you use the formula I equals, because everything here is the reducing balance and this per annum. So you're going to use the formula P into 1 minus I to the power n. And then what is the value of the car? It is 160,000 into 1 minus. What is the I? Right. So you're going to use the I. What is the I? Here it is. It is actually the the 12 you divide by 100. Okay. And then now you raise it to the power. Right. You raise it to the power. How many years are these? Right. Obviously, it's 4 years that we're dealing with, because Kai bought the new car 4 years ago. So you put 4 here, and then you just calculate and get the answer. So what is the answer to this? So yeah, it's 160, because 160 here, 160,000. That is the value of the car, but it depreciated. So you put 160,000 into 1 minus 12 out of 100 to the power 4. Right. So what I'm getting here is 9595, 9595. So you're getting 9595, 1, comma 2576. And we get this. So we get that one. So we're getting 95951, comma that. 95951, comma 2576. Right. And that is the answer. Right. So we're done with the Kai question, 3.2. Right. So I'm giving you 3.3. Assuming inflation over the 4 years is determined at, so we are saying inflation is 9%, because in 3.3 we're saying assuming inflation over the 4 years is determined at 9%. So we're saying inflation rate is 9% per annum. So I is, so now when they give you these here, they mean that I is this one. Calculate the current price of a similar new car rounded off to the nearest. Okay, the inflation over the 4 years, n equals 4, is determined at this. Calculate the current price of a similar new car. Right. So in other words, obviously at this point, you want to find the current price of a similar new car? Now, the P, what is the P? Right. So you agree that the P is still 160,000 because the car was like 160,000. But a similar new car in N equals 4 years, I equals 9%, the price of a similar new car. So what is the price? The price is the final amount. What is the final amount? So please do 3.3 and then let me know when you're done. Okay. And let me know when you're done. Okay. And let me know when you're done. Okay. All right. Okay, good. There we have it.
The identity could be identity. Okay, so the first question is the proof. What is it? We've got cause, prediction, alignment. I think
Right. Right. Let me know when you're done, please.
Almost done, sir.
All right, thanks. Right, so please let me know when you're done. Okay. Okay, let's see what you got. Right, you got that one. Let's just check together what the answer is going to be there in 3.3. So, um, we're dealing with 3.3. You have that. Right, so obviously in 3.3 now, we're dealing with the inflation. So it means that we are going to use the formula A equals P into 1 plus I to the power n. So so 1 plus, okay, so it's 9%. Right, so we have 9 divided by 100. Right, because it's 4 years, 9%, and then you have 4 years. So you put the 4 there, like that. So yeah, I think that you are on point. The most certain on point, because then that is going to be exactly 160. Then you're going to have 9 here. Right, so what are you getting? 225. 853, comma 05, 76, 225853 that. Okay? 2258. I'm looking at your answer. 2222. Then there is 58. Then you have 583, 583, comma 0. Okay, there's a small discrepancy, but I think it's the calculator thing. Whatever, yeah. But you see, the 0.42 is 0.05. Okay, but it's a small thing, so yeah, you can just leave that. Okay, next. Yeah, so but yeah, I agree with you. Your answer is pretty much correct there. It's just rounding off. Right, if you look at 3.4, the dealer offers Kai a 12% discount. Okay, now this is very interesting that the percentage normally appears as a rate, but it's not per annum, so it's a discount this. At the on the price of the new car. Calculate how much cash he must still find to pay for the new car after trading in the old car and withdrawing the investment. Okay, I want you to try this one. Okay, there's a lot. I feel we started in the morning. We need like the whole day, like hours and hours to do the finance, but we can't have the whole day because time is just not there. You're going to school, you're going to church, you have your own things to do, other things. So yeah, try 3.4. The dealer offers Kai a 12% discount. How do you interpret? I want to see how you interpret the discount on the price of the new car. Calculate how much cash must he still find to pay for the new car after trading in the old car and withdrawing the investment. So I want you to tell me what that one is. Okay. Okay. So, yeah. So please let me know when you're done. Okay. All right. Right. So we have that. So let me know when you're done, please. It's a bit tricky, this one. Okay, so you need to do it step by step. The dealer offers Kai 12% discount on the price of the new car. So we have already said here, calculate the current price of a similar new car. So how much is a new car? And then we calculate the discount. Okay, that's what you need to do. The price of the new car, then we less 15%. That's what we do in 3.4. Right. So in other words, we're going to take the price of the new car. Okay, let me see. You go 134303 that. Okay, I would believe that you're right. Okay, let's just look at it together. Right, so you're gonna take this price of the new car, this one, then you less 12%. So you have 225853, 0576. You less 12%. Okay, you less 12% of the same amount. 225853. 0576. Okay, you less 12%. That is going to give you 1987075. 75064. Right. So we have this. So right. So you have 50. Okay. Right. Okay. With this now, you have this. This is the discount. So it means that 12% discount, then he's gonna have to pay this, but okay. Is the dealer offers Kai 12% discount on the price of the new car. So he's not gonna pay the 12%. Calculate how much cash must he still find to pay for the new car. After trading in the old car and withdrawing the investment. Okay, so obviously now the investment. So the couple of things, so you need to take into account the investment. So you're gonna take the 19875 You subtracted the 12%, and then now you also subtract what? So you can write like this, 198 750.64. You subtract a couple of things, the trade-in. Right. So if you subtract the trade-in, you subtract also the investments. Right. So you're gonna subtract the trade-in. How much is the trade-in? Okay, you already got the trade-in. Okay, I'm gonna look at your thing. Right. Obviously, you have that the trade-in. You want to upgrade to latest model for years, invested that one. Right. Also, you must withdraw the investment. So the investment alone is going to be 60,000 for years at an interest rate of this compounded monthly. So which means that it's going to be exactly that one. So you have 60,000. Right. One plus 9 over 100, 9%. Right, which is 9.6. Yeah, 9.6. Right, and then is raised to the fourth power. Okay, but it's compounded monthly, so you must multiply by 12 here. But you must also multiply here by 12. So if you do that, it gives you 87,000. It gives 87,954,24. Right. So in other words, you also subtract here. This one is the investment because the 60,000 for 4 years at an interest rate of this was invested. So this one is the investment. Okay. So this investment is, you're going to subtract also the investment because it's going to take the investment, and according to this question, how much you must still pay after trading in the old car and withdrawing the investment? This is the investment, 87,954.24. Okay, then that's 87,000 of the investment. But also we have the trade-in. Right. How much is the trade-in? Because we did that one in 3.2. Because calculate the value of his current car if he paid this and depreciate on the reducing balance. So in other words, if he paid this, then the value of the new car is going to be this. So if he trades it in, this is the trade-in. The trade-in is 95,951,2576. That is the trade-in. So this is the trade-in. This one is the investment. So this one here is what? Is actually the amount that is supposed to pay after a discount, less the investment, less that. Okay. Right. So if you do this, and subtract everything. Okay, finance can be a little bit tricky, so you need to just make sure you understand the story behind the question. 0.64, 198,750.64 minus 87,954, 87,954.24 minus 95,951.2576. So obviously here it means that we have 14845, comma 1424. Well, the meaning then is that he must pay this amount of money. He must pay these. The investment will help him to pay the trade-in, but in the end, he must pay this. So he must pay 14,845 and like 14 cents. So you can normally we can round it off to 2 decimals. So it's 14,845. All right. All right. So that would be 3.4. This one is 3.4 that we're doing here. All right, now do 3.5, please. An amount of 25,000 is invested. Because it's invested, use the formula with the plus. This is the rate of 7.6% component monthly. So you're going to use the formula divided by M, but you divide I by M, but you also multiply by 100 in the denominator. After 2.5 years, this one is withdrawn and the interest changes to this one, compounded quarterly. How much will they be in the account at the end of 5 years? So that kind of thing. Try 3.5 and then we're going to do it together, please. Then we're going to do it together. Okay. Okay. Right. 3.5 is a little bit tricky, but yeah, try it. Let me know what you think. All right, please let me know what you think. 3.5 is what we're trying now. Three point five. Let me know what you think about it. This 3.5. All right, you done? Let me
Not
know.
yet.
Okay, that's fine. Okay, that's fine. That's all right.
So can you please do this one because I'm a bit confused about a few things.
All right, that's fine. Okay, that's fine. Right, and these are the kinds of questions you really can expect to meet tomorrow. So now, how do you do this one? You'd have to look at the fact that the amount of this is invested. So this one, because it is invested, it is the principal, this one. It's invested at this rate. So it means I is this one, and it's compounded monthly. It means M is 12, okay? But now anything missing here is the N. And after 2.5 years, 10,000 is withdrawn. Okay, so this withdrawal of 10,000 that is withdrawn, right? So this withdrawal is like an A because it's after 2 years, so it's in the future, so it's a future value, right? And the interest rate changes to 8.2% compounded quarterly. Calculate how much the interest is gonna be. Right, you can draw a small timeline, this one, in say time 0. The amount of 25,000 is deposited so that you can think clearly with the timeline. The amount of 25,000 is actually invested at the rate of 7.6% per annum, but it's compounded monthly. So you can write all that kind of information under the timeline. After 2.5 years, 10,000 is withdrawn. So now, remember, this is compounded monthly. So now, you need to look at the period and say, after 2.5 years, this one is withdrawn and the interest rate changes to this compounded quarterly. So you need to take 2.5 years. What is 2.5 years? 2.5 is like 2.5 times 12 because it's compounded quarterly. And then what is 12 times 2? Is 24 plus 6, which is 30. So this one is going to be 30, like 30 months, okay? Right, so it means therefore here you're gonna go up to T30. Right, time 1 up to T30 for 2.5 years. After 2.5 years, 10,000 is withdrawn. So the 10,000 is here in the future. It's like an A. This one is like P in the beginning, principal present value. Okay, and the interest rate changes to that. So the interest rate after this is going to become 8.2%. Compounded quarterly. Compounded quarterly. Okay, compounded quarterly, so this one is quarterly. Calculate how much would be in the account at the end of 5 years. So it means therefore, okay, at the end of 5 years, how much is going to be in the account? So, okay, it's quarterly, 2.5 years here, and then now you are supposed to go up to 5 years. What are you going to add? You're going to add another 2.5 years. But how many quarters are those? The 2.5 years. So you have 2.5 years, which is 2.5 times 4 for the quarters. Here you have 2.5 times the months, 12. Here, 2.5. Another, because we have 5 years. 5 years is, if you divide this by 2, it's 2.5 and then 2.5. So 4 by 2 is 8 plus 2.5 by 4 is what? Right, it's 8 plus 2, which is 10. So you have 10 here. So which means okay. Right, so we're interested in the future value. So we're going to use the formula because this is an investment. We're going to use the formula, this one. All right, you can just, the same with, you can divide by M, multiply by M there. So now the 25,000 here. 25,000 is invested at 7.6%, which is 1 plus. Okay, 7.6% compounded monthly. So the 7.6% you divide it by 100, which is 0.076. It's compounded monthly. So, yeah. Okay. I can divide by 100. I said we need to divide by 100 always, so you can just consider dividing by 100 always. So which means 7.6 compounded monthly 12 times 100. So right, you raise it to the power 30. Or you can say, because it's 2.5 years, so you can say 2.5 times 12. Okay, so an amount of 25,000 is invested at 7.6% compounded monthly. So you divide by 12 and multiply by 12. After 2.5 years, 2.5 years, 10,000 is withdrawn. So if the 10,000 is withdrawn, it means that the 10,000 is subtracted. You minus it from whatever. You take this 25,000, you push it to time 30. And then when you get there, you minus 10,000, because if you go to the bank and you withdraw money, you remove the money. So you minus it. Okay, so it's minused. If it's minused, then that money, You close like this. After minusing the 10,000, then the investment continues. Okay, they're saying here, and the okay, 10,000 is withdrawn, and the interest rate then changes to 8.2% compounded quarterly. Compounded quarterly, so it's 4 times 100. Okay, and then now you have 4 times. Calculate how much will be in the account at the end of 5 years. You had 2.5 years in the beginning, 2.5, and then to make 5, you need another 2.5. So which means it's going to be 2.5. Let me just remove this one. So which means that it's going to be another 2.5. So as a consequence, when you get to this now, you use your calculator. 24. 760. 75. All right, so I'm sure you sort of understand because the 25,000 was invested, 10,000 was withdrawn, so it's minus. After the 10,000 was withdrawn in the middle of the timeline, the investment continued for another 2.5 years, but it was quarterly now. So you divide by 4, you multiply by 4, but it's 2.5 years, etc. And if you do everything, the 10,000 was withdrawn, so it's minus, and you multiply everything, it gets to 24 that. Yes, question 4. Question 4 is about Thabo, is about Asanda, is about Mrs. Pillay, 4.3.1, 4.3.2, 4.3.3. I feel like we need to practice with these ones. Now, what do you think? Because it's already about 2 hours since we are on air, you know? But I feel we can discuss these ones as well. Let's just discuss them. Let's do 4 points. Let's do 4.1. Some of these are quite hard questions. Well, they have lots of information, so they're potentially confusing. And I feel that I need to give you a break. You need to rest because you're exhausted. But think about these questions. Think about these questions. I can ask you these questions. I'm going to pause the video in the next couple of minutes. Okay? But these questions are going to be there at the end of the video. So you can just fast forward the video and then try these questions. Okay? All the questions that have too many things like 4 years here, and then 2 years, and then 4 years, you need to draw a timeline for this. Because if you don't draw a timeline, then you're going to get confused. Even this one, let me see this one. 2 years here. Then 4 years here. This one is 5 years here. 5 years, 5 years. So, and here it's daily. Let's do Mrs. Pillay. Mrs. Pillay deposited 240,000 into a fixed deposit savings account for 5 years. The accumulated amount in the savings account at the end of the 5 years, or the 5-year period, is 390,000. Calculate the interest rate paid by the bank in each of the following situations. Okay, the effective annual interest rates. Okay, try 4.3.1. It's easy for 3 marks. Let me know what answer you're getting. I want, because now they can ask you tomorrow the effective annual interest rate, the nominal rate per annum, the nominal interest rate per annum, that kind of thing. Okay, compounded daily, what do you do? Because we did not do compounded daily. We did compounded monthly. So if they say compounded daily, how does it work? That's what I want us to discuss.
So in the compounded daily, I think we times by 31 or 30, depending on. So I'm confused.
Okay, that's fine, I understand. But compounded, it depends on how many days are they in a year. Compounded monthly, we say M is 12. In the formula, A equals P into 1 plus I divided by M raised to the power N M. Okay, so if they say compounded monthly, it means the M is 12. Why is it 12? Because there are 12 months in a year. We look at how many the things are in the year or in a year. So daily, how many days are there in a year? 365. So we're going to use 365. Okay. And then here monthly, we're going to use 12. Because there are 12 months in a year. Right? But I want us to do this question because I want to be sure that you can do it. So for instance, Mrs. Pillay deposited this one. So if Mrs. Pillay deposited this, it means that this is the present. Okay, it's P. Right. Next. Into a savings account. Paying, into a savings, in the fixed savings account after savings account for 5 years. So N is 5 years. The accumulated amount in the savings account at the end of 5-year period is this. What if they say accumulated amount? It means that it is the final one. Accumulated is the same as the final, which is A. So now you just go to the story and you put all the things there. Mrs. Pillay deposited. If you deposit, it is present. The accumulated is the future. Number of years is A. Calculate the interest rate paid by the bank in each of the following situations. The effective annual interest rate. We'll point that. What is the effective annual interest rate? Right, so you here in 4.3.1, you need to do it like this. Because this thing here is accumulated, so it's growing. So it's P into 1 plus I to the M, the N, we always say. Or you can use this one because it's 5 years and everything else that goes with it. Right, so the accumulated amount is 390,000. This is the amount deposited. Present. If you deposit now. The rate, what is the rate? So they want the rate. So yeah, you leave this one. You leave I. You have the 5 years. Which is 1 plus I to the power 5. So you have this one here. 390 divided by 240. 1 plus I. So, right. So 1 plus I to the power 5. So you have this. Which is 390 which is 1 plus I. So now you just take things here. So you minus 1. So you have 390, 240. Okay. Here you need the effective. The effective rate is the annual rate. But the rates become nominal when they are monthly, daily, and so on. They become nominal rates because nominal is daily, nominal is monthly, nominal is quarterly. So I. So you do this. So then you have 1 comma 19%. All right, so you have this. Okay, so that is the effective rate. Now, if they say calculate the nominal interest rates, okay, so this one's 4.3.2, the nominal interest rate compounded monthly. Please try the nominal interest rate and tell me the answer in 4.3.2. I'm giving you like 3 minutes because it's 3 marks. What is the nominal interest rate? So first, what is the formula for the nominal interest rate? What is the formula? What formula helps us to convert nominal interest rates to effective, from effective to nominal, and from nominal to effective? Okay. All right. What do you think the nominal rate is going to be in 4.3.2?
Still busy, sir.
Okay, that's fine.
Sure, I'm done, but I'm not sure about the answer. But I think the method is correct. So can you please do it so
Okay,
that I
let's discuss it. Okay, right. Because here we're saying the nominal interest rate. So obviously the question is we need to calculate the interest rate paid by the bank in each of the following situations. Calculate the nominal interest rate. So we use the formula 1 plus I effective is equal to 1 plus I nominal divided by what? Right. Divided by M. So this is nominal divided by M and is raised to the power M. That is the formula we use. Right, but we want to find the nominal rate. So we already know the effective rate. What is the effective rate? This is already the effective rate they've given to us. The effective rate is the one that is annual. So it's not monthly or anything. It's once a year. Right, so and we've already got that. So it's 1 plus, this one is already 10.19% is equal to 1 plus I nominal divided by, okay, because it's compounded monthly, so M is 12. M is 12. So you put 12 here and you put 12 there. And then you just need to solve for I nominal. Because it's 12 here, you actually add these two things. 10 plus 1 is 11.9%. So you take the 12th root on the left. Whatever you do on the left, you must do on the right, 12th root out of 12. So now you have 12. Right, so you minus 1 and then multiply by 12. Okay, minus 1, then you multiply by 12. Is I nominal? Okay, because you need the nominal rate. And then you can just get the answer. What is the answer out of this? Okay, so you take the, okay, remember that if there's here, I hope you're operating your calculator correctly because it's the 12th root. So you must choose that button that is a 12 there. It has an empty block and then you put a 12 there because that might be the reason why maybe some answers are actually a bit different, you know? Like what answer do you get here on your calculator? Please do it on your calculator. I want to see if you're able to use the calculator correctly.
So I got 459.72.
Out of these, okay, because I expect you to do the 12th root like this, and then it is 11,19. This is the percentage symbol, minus 1, then you multiply by 12. Okay, I'm interested in knowing the answer here. Because the answer I'm getting, right. Let's see. Right, the answer I'm getting is 2 points. 2 points. I'm checking my calculator. 2.67. 2.67%. Right, can you do it carefully, please, and check? Do it carefully, please, and check. Do it again. What did you say you were getting? Because I need to check that.
What answer did you get, sir?
Okay, I'm getting 2.67. If you do everything here. 12th, the 12th root of this, 12th root of 11.19. Okay, there's a small discrepancy. Okay, there's a small discrepancy, just check. Because this one here, is a percentage. So if it's a percentage, it's fine here, but you'll have to use the percentage. And it's going to create a small change here. So if you divide this by 100, because it's a percentage, you must divide it by 100. So it's going to be 1, 2. So it's going to be plus 1, which is 1 point. So divide this by 100 and add 1. That will be the most accurate way. Divide this by 100, so it's going to be 1, 2. Okay, so it's 0, comma that, but it's 1.1019. Right, so that'll be the most, so the decimal point is going to shift. Okay, that's what creates a small discrepancy. So you have here, which is 1.1019. Okay, so you come here. One 1.1019, okay? And then you come here. Okay, so you observe these things so that you make sure that you avoid mistakes tomorrow. Right, so you have 1.1019, okay? Then do it now and see. It's gonna create a small change.
So I got minus 10.99.
Okay, yeah, now it's like you're getting the right answer. Now you're getting the right answer. Okay, but I'm just gonna check. I'm checking as well. What are you getting?
Minus 10.99.
Minus 10.99. Okay, yeah, here is actually the answer that must be obtained. So it is 9.74%. Okay, yeah, so it is 9.74%. Can you do it again? Because it must be this. I want to see where your calculator is not giving you the correct answer, because you must like rectify it today, like right now, so that, because I want to see if you can be able to do like the 12th roots, like the 12th root, you know? Okay, so you have the 12th root, then you have that. And then the answer here is, what you're getting here is 0.0.
Sir,
Yes,
I got 0.097.
yes, that's the answer. But now, because you're not multiplying, because we don't divide by 100, so you must multiply this one by 100. Okay, if you
Okay, sir.
multiply it by 100, what does it become? That is the correct one. But you must just multiply it by what? By 100 to make it a percentage. In fact, effectively, you must multiply it by 100%. What does it become?
I got 9.74.
Yes, 9.74%. Okay, so that is the actual answer. So that is the nominal rate. Now, let me ask you another question. Please do 4.3.3. I want to see what answer you're going to get there. 4.3. The nominal interest rate per annum, if the interest rate was compounded daily. Okay, look at this. Now you are looking for the nominal. You already have the effective. What is the effective? The effective rate is 10.19%. The effective rate is 10.19%. But you need to get the what? The nominal. But it's compounded daily. And I was saying daily is 365. There are 365 days in a year, provided it's not a leap year, because a leap year has how many days? 366, isn't it? Okay. So Obviously, we're not speaking about a leap year. Okay, please, can you do 4.3? Do 4.3.3? I want to see what you're gonna do.
So
Yes?
I got 0.319.
Okay, 0.319, eh? Okay, let's check it together. Okay, and I'm saying that is late now. And you need to sleep. You need to do your own things. I'm gonna take a break. I'm gonna finish now. Right. So obviously at this point, we're interested in the effective rate, in the nominal rate rather. So we use the formula 1 plus I effective is equal to 1 plus I nominal. Nominal, you divide by M, you raise to the power what? M. What is the effective rate? We already got it. We got it to be 10,19. We used it here. So, but now we need to get the nominal rate when it's compounded daily. Daily, there are 365 days in a year. So, which means that if it's daily, then you use nominal is 365. And then you put 365 here. And then you just solve for the nominal. But as we indicated that this is one is a percentage. So you must divide this one by 100 because so it's 10 comma that divided by 100. Three, 365. Okay, divide by 100, it becomes what? 1 plus, it moves 1, 2 places. 1019. Okay, 1.1019. I nominal divided by 365 to the power 365. So you, okay, because 365, it means you take the root, the 365th root of 1.1019. And then it's 1 plus I nominal. So you minus 1 and multiply by that. Okay, so you can just, so you have 365. So you have this, which is I nominal. Okay. I nominal, right? So these things you'll understand them over time. You understand them over time. So which means I nominal. You deal with this. So if you use a calculator, what answer do you get again, please? Can you check?
So I got 0.0031.
But your answer must be close to this one. Because the fact that it's daily, monthly, it's just going to differ very slightly. So it must be close to like 9,7 or 0,09. It's 365 this, right?
Yes, sir.
Okay, I'm going to use this one. Just a minute. I'm going to use this calculator. Where is the calculator? There's a calculator on the screen. Right, so I'm going to use this calculator. This is my calculator here. Right, so if I use this calculator, let me put it on comp mode. Okay, let's use this. So we're gonna do this now. So we're gonna use 365, right? Open bracket. Then now I want to do the 365. So I'm gonna choose the correct radical formula. So because I need to put the 365 here, I'm gonna choose shift this one. Okay. So now I'm gonna do 365. Then I'm gonna do at the bottom. Right, at the bottom here. You can do this one, right? So you put here 1.1019, and then you do this, -1, and then you close, and then equals. What is the answer? Is that one?
Oh, so now I see I didn't insert the first 365 before the comma.
Oh yeah, I see. Possibly that's the reason. Right, so you can see that the answer you're getting is actually that one. So it is 0.0 that, right? So it is 0.0, need to bring that up, 97, 0.097, 05. Okay? So, but now you can just multiply it by 100, moving 1, 1, 2, which is equal to 9.7, 1, 2, 9.705 I nominal. So this therefore is the answer. Okay, so yeah, we have done this, and we've done it pretty in some detail, and I think that it's some good time to say we've done something today. So the I'll see you next time. Okay, but I'm gonna pause this video in the next couple of minutes. All right. Thanks,
Okay,
then.
so
Yeah.
thank
Have a
you.
good evening.
Thank you.
Yeah, we'll chat again. We'll talk again when we shall meet. Okay.
Okay.
Okay, thanks then, and goodbye.
Goodbye.
Mhm.